All right, welcome to the 10th stand-up meeting for the hashtag CSPT6 underscore Tico group at Lambda School, the part-time computer science cohort. As many of you may know, Lambda School has decided to provide everyone with the opportunity to have a spring break, especially with everything that's going on concerning coronavirus. I think that's great that the school decided to do that, considering a lot of the part-time cohorts, they are also dealing with children, so myself included, and so being able to find the child care services for your kids while you're working can be difficult. Studying without the right mindset can be difficult to maintain. So heart goes out to all those people that are dealing with that and that are affected by that. But I wanted to have this optional stand-up meeting tonight and also have it recorded in case anybody did need the support in the event that they would be sticking around to continue learning computer science, data structures and algorithms. We just finished the data structures sprint last week. So if you have any questions on that, that's why I have this meeting open here so that anybody can hop in and ask any questions. If nobody does hop in within the next 2 minutes, then I'm just going to be continuing where we left off in our mob programming session in stand-up meeting number 9, which is the Project Euler problem number 4. Let me go ahead and share my screen there. Okay. So Project Euler problem number 4. Largest palindrome product. A palindromic number reads the same both ways. The largest palindrome made from the product of two-digit numbers is 9009, and that comes from multiplying the numbers 91 and 99, which are, like it reads, two-digit numbers. Find the largest palindrome made from the product of two three-digit numbers. Okay, so last time we worked on this problem, we had, I believe it was Jonathan and also Chris Wernley. Leslie, I believe, was there at one time. Christina was there. And I believe that might have been it. But we do have some code from that time. I believe it's posted here in the channel. There it is. Christina posted it here. Let me grab that for you and we can share that. Okay, and I'll open up a replit for us here so you can follow along. Excuse me. Okay, let's go. Oh, there it is, Project Euler number 4. Okay. So I'll just go ahead and paste in the code that was dropped in earlier. Okay, so the kind of progress we'd made last time was just understanding the problem better. During last stand-ups meeting, Christina was joining us for the first time. So it was actually her first time seeing the problem, and we were taking it as an opportunity for Jonathan to explain that problem in a way that Christina would be able to understand, to see if the plan that we had in place was simple and effective enough that Christina could code it in C if she wanted, right? And we were only searching for the brute force solution just as a starting point. As you can see here, I did drop some code for the pseudocode that I used for the brute force solution when I solved this a while back. And we can take a look at that as well. So, all right, let's just go from here then. So when I see this problem, the first thing I think of is the understand phase of UPER, which is the framework that we've learned at Lambda School. And UPER stands for, let's go ahead and put this up top here. Actually, we can do like this here. we'll make some doc strings, make it a little bit easier. Okay, so lambdas, let me increase the size of that font for you. There you go, that might be a little bit easier to see for you. Lambda's problem solving framework. Ooper. For all you Michigan residents, you understand why I pronounce it Ooper versus upper. A lot of people in class have pronounced it upper, but I'm used to people saying Youper for the Upper Peninsula of Michigan. Those would be considered people from that area. So yeah, we can call this Youper or Ooper. But essentially, Ooper stands for, let's see, the U stands for understanding the problem. Then we have the P, which stands for actually devising a plan, but that's where the P comes from, plan. I guess maybe I should also specify this. So the U stands for understanding. The E stands for execute. Sorry, I spelled that wrong. Stands for execute the plan. Oh, sorry about that. And then the R stands for reflect and refactor. Reflect or refactor. So the general idea is that you can use this Ooper framework, this problem-solving framework, to solve any problem in your life, whether it's a coding problem, whether it's a problem at home. And oftentimes my 2-year-old will, she's just learning how to talk. So understanding her, I can also use this problem-solving framework, right? Do I truly understand the problem? Am I using everything that's been given to me to understand the problem? And so when you're given a prompt in a code challenge, you want to use your best efforts in that first phase or that first step of Ooper, understanding the problem. Make sure you're gathering all the information. Make sure that you are utilizing all of that to your best of your knowledge, right? And a good example of this would be if my daughter comes to me and she says, Dada, 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 and she says some words that I don't understand. I need to do my best to use other ways that I can understand the problem, whether it's visual cues, whether it's tactile cues. So like, does she have a fever? Does she have any other symptoms? That way I can truly figure out what the actual underlying problem is. So the same goes for this Project Euler 4 problem here, largest palindrome product. So the first thing we want to do in the understand phase is we want to make sure that we define anything that we don't understand. That's where I generally first start. So let's go here and define any unknown terms, right? So I'm going to go ahead and create another set of doc strings separate from what Christina and Christopher and Jonathan have so nicely put together for us down there. So let's start with understand. So the first thing we're going to do is we're going to define any unknown terms that we have. So let's define some terms. So we have a palindromic number and reads the same both ways. Well, if you were like me, the first time you had done this problem, you probably had heard of a palindrome, but you didn't really know what it was. So what's the easiest thing we can do? We can always look it up. Or, if you already know what it is, then you can use your knowledge there. So a word, phrase, or sequence that, I'm sorry, let me increase the size of that for you. A word, phrase, or sequence that reads the same backward as forward. So an example would be Madame or Nurses Run. So if you were to write Madame backwards, it would be Madame. And if you write nurses run backwards, minus the space character in there, it would produce the same set of characters both ways. Okay, so here they're talking about palindromic number, but it's good that we define palindrome first, because a palindromic number would essentially fall into the larger category of palindromes. So let's do that. Let's go to our replit and let's put in here palindrome. And we can say a string of characters that reads the same forwards as it does backwards. And we can even give an example to help people who are going to read this that won't be able to speak with us and won't be able to dissect the problem further with us. Before I became a Lambda School student and pursued software engineering, I was in the physical therapy field. And in that field, we have to do daily documentation on our treatments with our patients. And we were taught in school to document in a way that's detailed and concise enough that somebody who has never met you or has never watched your treatment can reproduce that same exact treatment and the effects of that treatment for the same patient using all of the same therapeutic modalities and exercises that you've used. So in the same sense, we want to do the same here for our pseudocode, right? Okay, so an example would be like Madame, like we read earlier. And then an example of one that includes that space, like we talked about, could be taco cat. Okay, so we've defined a palindrome. Now let's see, let's go back here. So it says a palindromic number reads the same both ways. So we can go, oh, sorry about that. We can go back here and we can further define something more specific than palindrome, palindromic number. A string of, did I spell that right? Characters. why don't I feel like I can spell characters correctly? That's funny. Okay, I did spell it correctly. Now, I mean, I didn't spell it correctly before. Okay, so we can say that a palindromic number then is a string of numbers. We can even be more specific. So we'll say a string of integers that reads the same forwards as it does backwards. And let's go ahead and provide some examples there. Let's do 101. Believe it or not, a single character also counts. Let's not call it a string, right? Because we might get confused with the actual data type of a string. How about we call it like the definition provided for us on Google said, a sequence. I think that might be a little more accurate. Okay, so a sequence of integers that reads the same forwards as it does backwards. Let's maybe provide one more example here. Let's go 1532, 351. Okay. All right, so what's next, Tico? Well, if we go to the problem here, is there anything else in this prompt that we need to define before we move forward? The largest palindrome made from the product of two-digit numbers is 9009, which comes from multiplying 91 and 99 together. Find the largest palindrome made from the product of two three-digit numbers. So, I mean, we can automatically assume that we understand what a product is, but let's just, how about just for more reps, we just define that so that nobody can say that we didn't define it, right? Always got to watch out for those haters out there, right? So product, the result of multiplying two numbers together. So let's assume that that's what a product is. the resulting number, how about that? When two numbers are multiplied together. Cool. Okay. So we have palindrome. I like readability. I'm a big fan of readability. Okay. Let's create some space there. Okay, so we have palindrome, palindromic number, and product. Let's go ahead and look back again. We got about 8 minutes here. Actually, I started about 4 minutes late, so we'll take it 12 more minutes then. Okay, so the largest palindrome made from the product of two-digit numbers is 9009, which comes from the multiplying 91 and 99 together. Find the largest palindrome made from the product of two three-digit numbers. So we go from the example they provide here. We go from palindromic product to, palindrome, and then we also see palindrome here as well. So there's nothing there that needs to be defined else. Let's go back to the replit. Okay, so the next thing I like to do whenever I am working through the understanding the problem phase of Ooper, I like to define, actually let's do this, establish expected inputs and outputs. And this kind of comes from the idea of testing. So the reason why we have tests in software engineering is so that we can always be prepared for what we are expecting to receive, and then comparing that to the actual outcome of our code. Like we want our code to be maintainable, we want it to be readable, we want it to be extensible, and we want it to be predictable, because stable code is predictable code, right? So with that said, I'm gonna go back here. So establish the expected inputs and outputs. Okay, so if I were creating an algorithm that would somehow find this largest palindrome made from the product of two three-digit numbers, the first thing that comes to my mind is, what's the difference between the example that they provided here, the two-digit numbers, and the three-digit numbers? It's the number of digits, right? And so in my head, those wheels start spinning, and immediately I think that I want to create an algorithm that will, or a function that will take in one input, right? And that input, whatever you call it, in my case, I believe I called it, let me increase the size of this here. So I believe I called it, yes, num digits, okay? And so just like I put here, I kind of go in a little bit more in depth, right? I talk about the number of expected inputs, because you can have more than one parameter in any function. So here I just want one, and I'm going to call it num digits, and this will represent the number of digits in each integer that are multiplied together to get a product, right? And then later on we will evaluate that product and determine if it is a palindrome first, and then after that we will determine if it is the largest palindrome that we've encountered thus far. So let's go ahead and copy this here, and we can go ahead and add it into our replit. Okay, so actually right down here, let me format that nicely. Okay, so number of expected inputs is one. And then now we have to think about the outputs. Like, what are we looking to return? And if we go back to the problem, it says find the largest palindrome made from the product of two three-digit numbers. So what is this, right? We can see that it's only going to be one output. It's going to be the largest palindrome. And we can see from the example they provide that the largest palindromic product is 9009. So we can just infer that it's just going to be a single output, and the data type is going to be that of a number, or I guess in this case, an integer for Python. So we can go down here and let's go ahead and grab that from my code as well. So expected outputs, we just have one. We're going to call it the largest palindrome, and that's going to represent the largest palindrome made from the product of two numbers. How about we put two n-digit numbers here? Two n-digit numbers. All right. Okay. Let me actually get rid of that, format that there. Okay. So now that we've covered the number of inputs and outputs, and we've also covered the type of data, right? We said that this is going to be an integer, and we also said, actually we didn't say here. Did I include that there? No, I did not. So actually, let's do that. Let's say data type. So the data type of the input, we'll say, is going to be an integer. Okay, and we can copy that, and we could do the same for our output, except we'll change this to output data type. So like we talked about before, understanding what you're expecting, whether it's inputs or outputs, super valuable, because then as soon as you get an outcome, an actual outcome, you can compare those two things and say, is this what I was looking to receive, or is it different than what I was looking to receive? And it's easier to diagnose problems and debug, right? So, okay, let's go to the next thing, which if we scroll up to the top here, the next thing that we're going to be doing in the understand phase is going to be, let's see, evaluate for any constraints. So when I say constraints, I'm referring to those constraints that are provided to you in the problem, or any assumed constraints that you might have. And these are good questions to ask the interviewer. Part of the interviewing process, from what I've learned, is sometimes interviewers will often provide a very vague prompt in a problem in an effort to see if the developer is detailed enough to understand that they don't have all of the information they need to make an assessment. So they're looking to see whether or not a developer is going to ask those questions to dive deeper into understanding the problem, because if you start coding too quickly, you can miss these edge cases and these constraints that actually affect the outcome and ultimately the optimization of your solution. So I think it's really important to always consider constraints. So let's look at this problem again here. We got about 4 minutes left. Okay, so palindromic number reads the same both ways. The largest palindrome made from the product of two-digit numbers is 9,009. That comes from 91 times 99. Find the largest palindrome made from the product of two three-digit numbers. So just for me reading this, when I think about constraints, right, the things that immediately come to mind are, what can I throw into my function to try to break it, right? Yeah, that's really the only way that I can, I guess, rationalize this or like explain this process in my head. You want to try to break your code before somebody else does. And so like the more criticism and the more feedback you can get, even from the interviewer, that will help you produce a more solid, more stable code. So in the pseudocode that I wrote for the original solution that I came up with, I talked about floating point numbers, right? So if I put a number with a decimal in there in this num digits as an argument there, will it break my code? It may, right? Because if we look at the example they provided, I mean, they're just talking about two-digit numbers. You don't see any decimals here, or here, or here. And so we automatically assume that, that no, you cannot use floating point numbers or decimal numbers. And then, can the numbers be negative? Well, let's go ahead and look at these again here. So integers actually can be negative. Numbers can be negative. So it doesn't actually say anywhere in here whether or not you can use negative numbers or integers. And in most hacker rank problems that you'll encounter, there usually is constraints that are provided, whether it's something like it'll usually utilize comparison operators. So it might for instance, your argument or your parameter may be like n, right? Let's call it n. The constraints that they would provide would be something like 0 less than or greater than, less than or equal to n, which is less than or equal to 100. And that would tell you that the number that you're passing in as an argument to your function or algorithm must be equal to 0 or greater than 0, and then less than or equal to 100. So that means it has to be a positive number. So let's go ahead and copy this from my pseudocode and we'll put it in here. Okay. So any constraints, let's see. We said, can the numbers be floating point numbers? And we just assume no. Can the numbers be negative? We said maybe. How about like for this case, for this problem, let's assume no. All right, but essentially in the actual interview, I think it would make the most amount of sense to ask your interviewer and to use that as a specifying question to, one, show the interviewer that you are somebody who's detail oriented and looking to cover all edge cases. And then two, it's going to provide you with more information to write more solid code, right? Okay, so we go back up to the top here. So we've defined any unknown terms, we've established the expected inputs and outputs, and we've evaluated for any constraints. Now, this last part, it's something that I do because I feel like it helps me understand the problem better. I don't necessarily know if it's something that you want to do yourself, but you can definitely incorporate it into your interviewing strategy based on the time that you have. But I would say, let's see, I would say run through a few examples of the algorithm or the function that you're thinking about implementing, whether that's the example that they provide or one that you provide for yourself. Just because running through these examples in your head or even in the pseudocode can actually help you better understand the problem. And that's what we're ultimately trying to do, is to best understand the problem before we start coding. Okay, so it's actually 10:05. I'm gonna finish up this last piece and then I will close and then we will continue this tomorrow. Okay, so run through a few examples. Okay, so we're going to run through a few examples. And I think we can do this format a little bit nicer. And let's do examples. Okay, so if we have this imaginary algorithm or function that we haven't yet created, and it's just going to take in one input, like we talked about, and it's only going to have one output. It's going to return one output called largest palindrome. And then it's going to take in one input called num digits, both of which are going to be data type of integer. We can put an example in like this. So let's say input, and then we can have an output. So let's say we put in, based on the example that they provide in the prompt, the largest palindrome made from the product of two digit numbers is 9009, right? So knowing that, let's go back to our replit. So if I put in the number 2 as my argument, right? And we can say, this can remind us, represents the number of digits in the integers being, well, let's say that represents the number of digits in the factors. Okay, so factors here, we can assume that factors are the numbers that make up a product. So we will go ahead and amend this in our understand phase here. So AKA also known as factors. And that's something that you'll notice when you're working through the Ooper problem solving framework. It's okay to go back and forth and fluidly move between all the different phases, right? I mean, that's actually part of Ooper. That's actually the last part, reflect and refactor. So reflect and refactor doesn't necessarily just refer to the solution that you're coding itself, but also to the pseudocode that you're writing. And that helps you better understand the problem, which is ultimately what we're trying to do. Okay, so like I said before, if we pass in the number 2 into our algorithm or our function, that represents the number of digits in the factors that we're multiplying together. And like we saw in the example, the output that we can expect is 9,009. Okay, and we can even clarify again, represents the largest palindrome. When with 2-digit factors. Okay, and I'm gonna move this over so it's a little bit more readable. Okay, so I mean, I normally do like 2 examples, but for this case, let's keep it more succinct. We'll just put that one example there. I guess the only other example we can do without doing the actual problem is having the input being 1, right? Which represents 1 integer for each factor being multiplied together. And we can know that, so anytime you multiply 2 numbers together, let's see. So the highest single digit number we have is in our, I guess our digit system would be 9, right? You have numbers 0 through 9. So let's put this in here. So 0 to 9, right? Those are the ones we're working with there if our input is 1. So I mean, then you can imagine, right, that we're going to be doing 1 times 1, 1 times 2, and so on, right? So when you get those numbers multiplied together, we essentially would have the highest in that sequence. There would be 1 times 9, which would be equal to 9. And then once you start multiplying numbers that are bigger, you're going to start to see resulting products that are going to have more than 1 digit in them. So like if you did, 9 times 9, that's 64, but 64 is not a palindrome, right? So in this case, we're actually not quite sure, and so this would actually stop us up. So good thing I didn't, I just threw that up there as something that you could do. But with time being of the essence, it would definitely be nice to just stick with what you know for now. Okay, so we've done 4 things in this understand phase so far, which is define any unknown terms. We've established the expected inputs and outputs. We evaluated for any constraints, and we ran through a few examples. How about run through at least 1 example? That would be better. There you go. Okay, so I'm gonna click run. I think that saves it, right? Hopefully. But yes, thanks for joining in with me here today. Please stay safe. Please wash your hands. Please follow all of the precautions that our government has put out there for everybody. I don't know who is from Michigan, but I'm from Michigan. And tonight, in 1 hour and 48 minutes, the government will be putting in a stay-at-home order in effect. So I believe that school is out until April 13th. My wife is a teacher, so we're also dealing with that. And yeah, continue to be safe, continue to work hard, continue to push yourselves. Also take the breaks if you need them, right? That's why Lambda is giving everybody this spring break, so that everybody can collect themselves, regroup, and put themselves in a better state of mind to continue learning these difficult CS concepts. So with that said, signing off here. Thanks again for joining. We will see you tomorrow. All right. Thank you and have a good night.